Hello, this video is going to be on applications of rational expressions, basically word problems that end up with as a rational expression. The first thing I want you to think about with this type of word problems is the rate of work. How we would write the rate of the work. If t is time, so let t equal time, then we're going to do 1 over t is going to equal the job per unit of time. And that's kind of a big idea, like we're going to write it as 1 over t for the rate of work. So let's look at an example that kind of walks us through this. So I'll put on my other paper so I don't have to write it out. So Joe takes 7 hours to clean the church. Bill takes 5 hours. How long will it take them together? So Joe takes 7, Bill takes 5. Let's use this idea of 1 over t and see how long it would take them together. So we would set the problem up like, okay, if it takes Joe 7 hours, it would be 1/7 for him. And we're going to add that if it takes Bill 5 hours, and we want it to equal 1 over x. There are a couple other ways to look at this problem, but this is the most common way or easiest way to think of it. Then you just solve this expression just like we have been. So a common denominator would be 35x. 7 times 5 times x is 35x. So I'd take 35x and I times it by each fraction. Okay, and then here, right, the 7 will divide into 35, leaving 5x. So this whole 1 turns to 5x because 5x times 1 is 5x. And then the 5 goes with the 35, leaving 7. 7x times 1 is again 7x. And then 35, this one, the x cancels, so you have 35. Some people can get here with their logical thinking. I cannot. So then from here, we add the 7 and the 5. And that's going to give us 12x equals 35. And then you divide and you get by 12. And you're going to get the decimal of about 2.9. Right? Double check that. 35 divided by 12. Yeah, about 2.9. And so that one's going to equal how long it took them together. The other thing I was thinking of, all right, so what if I wanted this to be written in hours and minutes instead of 2.9? Sometimes the book won't, or the My Math Lab or the book, or they want it in hours and minutes. So we know 12 goes into 35 two full times, and then how many remaining do we have out of that 12? We have 11, right? Because 36 would be 3 times. So let's think of this as we have 11 twelfths as our remainder. How many out of 60 is this if we wanted it in terms of minutes? So we know we have 11 twelfths left over, but we have that 2 hours here. We're just looking at the 9 here, or the 0.9, or the remaining part. So you can solve this proportion by 11 times 60, which is 660, and then 12 times x is 12x, and you divide and you'd get 55. So we can get the minutes by doing a proportion of 60, right? So we would have 2 hours and 55 minutes. And I kind of wanted to walk through this portion because a lot of people would get confused and they just put 2.9 and get it wrong and not understand why. So they might want it in terms of not just hours, because this is hours, but hours and then minutes. Kind of depends on the problem. Okay, so the next one I want to show you would be a little bit different. Okay, so what if from Boise to Portland I average 51 miles per hour? If I could have drove 60 miles per hour, I would have reached Portland 3 hours earlier. Not true, because it's really not that long of a drive. How many miles is it to Portland? Okay, so we're using miles, so it's more of a distance here, but we're going to average 51 miles per hour if we could have drove 60. So here's how I think of this one. We're going to have X be our miles to Portland. And if we did let X be our miles to Portland, then we could think of what I really did do, which was 51 divided into our miles, or our rate dividing into our distance, because distance equals rate times time, but distance divided by rate could also be equal as well. Sorry, I'm really sick. Pause my drink hot liquid to finish this video too. Okay, so then over here, we know that if we would have went 60, we would have been able to go um, we would have got there 3 hours earlier. I'm feeling like that should be hang on just a sec. Okay, so then from here I just need my common denominator. And the common denominator for this one would be like common denominator 3060, these two numbers just being multiplied. So if I multiplied that by all three spots, I would end up with 60x here equals 51x here, and then I would have 980, or sorry, 9,180. And then if I solve this down, I get 1,020 miles to Portland. So the one or X over is the bigger concept that you need to come out of this. And the idea is really distance divided by your rate when it's this type of problem. So you should be forming fractions with letters, just like we've been working with in this chapter 7 or whatever chapter, but in chapter 7 for this Math 108 class. So um, anyway, so there's two examples. The word problems, you just really need to work your best and do your best through them because they're a little more challenging to come up with on your own. All right.